question is, what is the 10th term in the sequence 1 over 3, 1 over 7, 1 over 11, and so on? So the given sequence is 1 over 3, 1 over 7, 1 over 11. So this sequence is an example of harmonic sequence. This is an example of harmonic sequence. And as you notice, the numerators are the same. All of them are 1. Well, the denominators form an arithmetic sequence. We have 3, 7, 11. So we simply disregard the numerator and we focus in the denominator. So we get 3, 7, 11. With this pattern, we already know that the first term, so we can already write ace of 1. We can now state that the given are the following. The first term is given, which is 3. Aside from the first term, we also know that the number of terms in the problem is 10 from the statement 10th term. And we also know the common difference, which is 4. We obtained the common difference, by evaluating here in the given sequence that is the constant number being added repeatedly in the sequence. 3 plus 4 is 7. 7 plus 4 is 11. So with these three values, we can now find the 10th term in the sequence, applying the formula for arithmetic sequence, which is base of n is equal to the first term plus the quantity n minus 1 times the common difference. So we use this formula, we apply this formula in order to find the value of the 10th term. So we are looking for the 10th term. We know that the first term, which is 3. We know that there are 10 terms and 1 is constant. We also know that the common difference is 4. So with this, we can now continue solving the equation by following the operations. We first subtract 10 minus 1, which is equivalent to 9. And then next step, we apply first multiplication. 9 times 4 is equal to 36. And then finally, we need to add 3 plus 36, which is equal to 39. So we have the answer. The 10th term will be 39, but since this is harmonic sequence, we need to write it as a fraction. Therefore, we will be obtaining the answer as we will not end with equals 39. We still need to write it as 1 over 39 because this is a harmonic sequence. So we have the answer 1 over 39 is the 10th term of this harmonic sequence. Any questions with harmonic sequence?
None po.
Yeah, walang question. So there's no question. Now let us proceed with the next sequence. So the fourth special type of sequence is what we call the Fibonacci sequence. Fibonacci is a name of a mathematician where the sequence was named after. So he is Leonardo of Pisa, who is later known or named as Fibonacci. So when we say Fibonacci sequence, it is a sequence where the first two terms are either both 1 or 0 and 1, and each term thereafter is obtained by adding the two preceding terms. So to explain this definition, let us translate it in a sequence. Let us first use a sequence with this condition that the first two terms are either both 1. So if we will write it in symbol from the given description of Fibonacci sequence, the first two terms are both 1. So it can be 1, 1 from the statement that the first two terms are both 1. And then the third term after 1 will be obtained by adding 1 plus 1, which is 2. And then the next term after 2 will be obtained by adding 1 and 2 equals 3. And then the following term after 3 will be obtained by adding 2 and 3, 5. Next, the next term after 5 will be obtained by adding 3 and 5 equals 8. Next term will be obtained by adding 5 and 8, 13, and so on. Did you see the pattern?
Yes
Hello?
po.
Yes
This is
po.
what we call the Fibonacci sequence. And maybe some of you have able to um, encounter the sequence. The other case will be from the definition, it can be started with 0 and 1. So, ma-start to 0 and 1. And same na, yung sunod na. Same terms. Okay, so this particular sequence is very known because of this idea. If you're familiar with this is what we call the golden ratio or the golden rectangle. Okay? The Fibonacci sequence is present in golden rectangle. Let me show you how it is possible using Fibonacci sequence. So I will be showing a slideshow. May slideshow ba sa presentation?
Wala pa po.
Wala. What is in your screen? What can you see in the PowerPoint presentation?
Yung presentation pa lang po, pero hindi
Which
pa po
slide?
nagpe-play.
Which
Slide
slide?
10 po.
Slide 10. The slide with squares of different colors.
Yes.
Opo.
But there's no animation.
None po.
May lag kasi pag presentation. Anyway, we will not use the animation. Anyway, okay, let me show you this example. Okay. So here, so if we begin with one square, the yellow one, the small yellow square, that is counted as one, so one square, and then we add another one. So from the sequence, 1, 1, so the first one, the small square, the yellow, and then another one, same, identical square. And then next will be 2 by 2, the green, the four green squares will form 2 by 2. So ito, 1, 1, ito naman, 2. So this particular rectangle is a golden rectangle composed of the numbers 1, 1, and 2, or 2 by 2. And then next, to form another golden rectangle, we will apply 3 by 3 here. Still, another golden rectangle is formed. 3 by 3. So 1, 2, 3, and then if we apply another, this time 5 by 5, the red squares, this is 5 by 5. So we have another. Still, we formed a golden rectangle. Next, we need 8 by 8, 8 by 8 to form also a golden rectangle using 8 by 8 squares. So the numbers are 1, 2, 3, 5, 8. Next, if we apply 13 by 13 squares, we form again a golden rectangle with a golden ratio at this point. And if we continue the pattern by adding 8 and 13, we form 21. So another 21 by 21 here. And that is what we call the golden rectangle following Fibonacci sequence. What is the purpose of that golden rectangle? If you have time, you can search that in the internet and you will see some applications like this in photography. In photography, the rule of golden rectangle is being followed to ensure that pictures are pleasing to the eyes. Professional photographers use the golden rectangle in their pictures. Okay, for example, this picture, as you can see, there is the application of golden rectangle. Even in movies, okay, in movies, those movies may contain the rule of golden rectangle to show that the the frame is pleasing to the eyes. Okay, so the point is in this particular concept, Fibonacci sequence is applicable or applied. They are related to one another.